Unit conversions. A bronze alloy is made with 88 weight percent copper and 12 weight percent tin. So we're going to perform unit conversions for this alloy. Given our elements, which are copper right here, and tin, which are right here. The atomic number of copper is 29, and the atomic number of tin is 50. The atomic weight percent of copper is going to be 63.5 grams per mole, and the atomic weight of tin is going to be 118.7 grams per mole. We're also given the density of copper and tin. For copper, it's 8.96 grams per centimeter cubed, and for tin, it is 7.37 grams per centimeter cubed. Our first calculation is to calculate the number of copper atoms per centimeter cubed for pure copper. So the important things to note is we're looking for atoms per centimeter cubed, and we're using pure copper only. That means we don't have to worry about the tin for this problem. First off, we're going to want to find a measurement that uses centimeters cubed, which is going to be our density right up here at the top. That's in grams per centimeter cubed. So if we take the density of copper, which is 8.96 grams per centimeter cubed, and now we want to try to get to atoms per centimeter cubed. So first off, we need to eliminate the grams, which is done by multiplying it by the inverse of the atomic weight. This goes ahead and gives us 63.5 grams per mole, as taken from the table above. If we go ahead and multiply these two, we can see that those will cancel out, and now we're in moles per centimeter cubed. This isn't quite what we're looking for, though, because we need atoms per centimeter cubed. So the quantity we need now is Avogadro's number. That's 6.02 times 10 to the 23rd, and the units for that are atoms per mole. If we go ahead and use this quantity, we can go ahead and convert now to atoms per centimeter cubed. So we multiply what we have so far by 6.02 times 10 to the 23rd atoms, and that's going to be per mole. And now our units of mole cancel, and we're left with atoms per centimeter cubed. If you multiply these out, it's going to yield 8.49 times 10 to the 22nd. This is going to be copper atoms per centimeter cubed, which is exactly what we're looking for. And that's the answer for our first conversion. For our second conversion down here, we need to calculate the atomic percent tin in the bronze alloy. So first off, we know that we have 88 weight percent copper, and we have 12 weight percent of the tin. In order to do this calculation, we need to convert our percentages to mass, so we can go ahead and do 1% is equal to 1 gram. This ensures that we still have the same weight percent, but now it's in units that we could use. This then results in 88 grams of copper and 12 grams of tin. If we go ahead and look at that fraction, we can see that this is still the same weight percent. We're just going to go ahead and make it out of 100 grams instead of an unknown quantity. Our first step now then is to convert our grams to moles. So we have 88 grams of copper, and we can go ahead and multiply that by the atomic weight, or the inverse of the atomic weight, which is going to be 63.5 grams per mole. Doing that, our grams cancel out, and we simply have moles left, and it's going to yield 1.386 moles, and that's of copper. We're going to go ahead and do the same thing for the tin. So we have 12 grams of tin, and we have moles, and the atomic weight percent, seen from the atomic weight from the above table, is 118.7 grams per mole. So the grams cancel out, and we get the answer of 0.101 moles of tin. Now we want the atomic weight percent. So we have the two atomic values, but we need to go ahead and get the percent. So we have our moles of tin, and we're going to want to divide that by the total moles. So moles total. This is going to give us the atomic percent of tin if we multiply it by 100%. Using these values then, we can do 0.101, and we'll divide it by our total, which is going to be the sum of this, the moles of copper, and this, which is the moles of tin. So 0.101 plus 1.386. Multiply it by 100%, so we can do percentages, and that's going to go ahead and yield the answer of 6.80%. So the atomic percent of tin in this alloy is 6.80%. Our final calculation is to calculate the volume percent copper in the bronze alloy. So what we need to find is copper, and it's for the bronze alloy, so we're going to go ahead and use the same percentages. Just like before, we're going to go ahead and associate 1% of each element with 1 gram. So if we have 88 weight percent copper, that's going to go to 88 grams, and 12% weight tin is going to go to 12 grams. We also know that volume is mass divided by density. Now we have mass from these two quantities given, and we have density given from the table above. Doing that, we can go ahead and find the volume of the copper. So we take the mass of the copper, which is 88, and we're going to divide that by the density, which is 8.96, as seen from the table up here. And this is going to be in grams, and grams per centimeter cubed. Plugging that in, we get 9.82 centimeters cubed. And we'll do the same thing for the tin. So we have 12 grams of that, and now we look again at the density at the table up here, and that's 7.37. So we'll go ahead and write that, 7.37 grams per centimeter cubed. And plugging that in, we find it is 1.63 centimeters cubed. Now, just like before, we're trying to find percentages, which means we need to set up a fraction. So the volume of copper, that's what we're looking for, volume percent copper, divided by the volume total. That's going to go ahead, taking our numbers over here, 9.82, that's in centimeters cubed. Divide that by our total, which will be 9.82, plus the volume of the tin, which is 1.63, both in centimeters cubed. The units cancel out, and we'll multiply it by 100% to get a percentage, and that's going to yield 85.78%. And that's going to be the volume percent of copper as requested in the problem, so we're good there.